Okay, question number 156. Determine the force couple system at O. So at O, so it means that you need to find the moment of these two forces at the point O. So let us first find the components. F1. This is one component, and as you see, this component is in positive z direction. What is the unit vector of the z-axis, positive z-axis? K, yes? So how much is this magnitude of the z component actually of the F1? 600 cosine 30 is the magnitude of this one. What about the other one? This is the other component. So it will be 600 sine 30, and it will be in the, you see, look at the y-axis. They are parallel, so it will be plus j. It is positive. So let us write the F1. 600 sine 30 plus j, times j, and 600 cosine 30 k. Actually, times k is also correct, or times j, but you can just say j and k, which are the unit vector for the y, this one, and this is for the z axis. What about F2? Look at here. This is when you see this angle, so it will be 800 cosine 45. It will be this component, and the other one will be sine 45. 800 sine 45. So this one is in the y axis, so it is negative because it is directing in the negative y. So it will be 800 sine 45 times negative j. This one's. What about this component? 800 cosine 45, and the unit vector of this one, the z-axis, is plus k. So I will put k here. Okay. Now we need to find the resultant force. We just add them up. You can use your calculator. I will just obtain one of them for you. So remember, first in the exam, find the sine of 30 to make sure that it is on the degree, not radians. So sine 30 times 600 will be 300, easy. So this will be equal to 300. You can write it 300 j plus, so cosine 30 cosine 30 times 600, it will be 500. You can just copy. I'm sorry, I'll put a, should put plus here. Okay. Okay, and for this one also you do the same. Let us find 45 sine 45 times 800. It will be 565.9. Because this is 5, it will be 9. Times j, but it has a negative. Remember to put the negative here, negative sign, and Cosine and sine of 45 are the same. So this will be same. Okay. And then you will add this to. Okay. After finding the R1 and R2, we want to find the moment at the point O. So we need to find R1 cross F1, R1 cross F1, and R2, the orange vector, times across F2. We need to use the determinant. So in the determinant, in the first row, you put I, J, K. These are the components of R1. And the third row are the components of the F1. And this is the second row for this one is R2. And the third row is F2. Components we copy from F2, which are here, negative 565.69. You can just, here I put negative 800 sine 45. You don't need to do that. You can just copy this and put this here, like this. Okay, then we will obtain the determinant, these two determinants, which are two vector. For example, this determinant will be equivalent to this vector, and the first one is equivalent to this vector, and we will add them up. So this will be the force, the equivalent moment at the point O for these two systems. And we have already obtained the resultant force. So we find the force coupled system at the point O.